Hello and welcome to IP lesson. In this lesson, we will do the STP Lab. This is the lab that we will do for STP protocol. In our lab, we have switch 1, switch 2, switch 3, and switch 4. There is one redundant link between the switches, and the redundant link is a backup link, and if we remove it, our switches will still can reach each other. For example, if we remove the link between switch 1 and switch 2 can go through switch 4, then switch 3 in order to reach switch 1. So let's first see the messages that will be exchanged between the switches when we turn on our devices. So here is our lab, and let's start the switches in order to see the STP messages. So the first message will be the STP protocol. If we click in one of those messages, and then go to the inbound BDU details, it will tell us details about the STP protocol. Here we have the root ID. It still didn't calculate the path cost yet. Here is the bridge ID, port ID, max age time, and the hello time. So what is the STP modes that we can configure in Cisco switches? So this is kind of tricky on Cisco Packet Tracer. So if we open our switch in Packet Tracer and did the command spanning tree mode, then question mark, it will show us the STP modes that we can configure on Cisco devices. So as we mentioned before, that Packet Tracer is a very good tool and help us to practice Cisco devices labs. But as we mentioned before, the downside of Packet Tracer is that it doesn't support all the commands. So in Packet Tracer, Cisco switches, it will show us BVST, which is Bare VLAN Spanning Tree Protocol mode, and Rapid BVST, which is Bare VLAN Rapid Spanning Tree mode, or Rapid Bare VLAN Spanning Tree Protocol. But if we did this command in a real Cisco switch, it will show us that it supports MST, BVST, and Rapid BVST. So back to our lab, let's open our switch and see the spanning tree modes that we can configure on Cisco devices. Here is my switch. I will go to the global configuration mode in order to be able to see the spanning tree modes. Enable, conf T or configure terminal. Then let's do a question mark here. And as you can see, we can do the command spanning tree. So let's do the command spanning tree, spanning hyphen 3. Let's do another question mark. And here we can do the command mode, portfast, or VLAN. So as we mentioned, Cisco switches doesn't support the CST or common spanning tree protocol, which block one port for all the VLANs. Instead, the blocking will be based on VLAN. So here we can specify VLAN in order to specify which VLAN we need to change the configuration for. So let's continue with our command. I will put the command mode, and after that, let's do a question mark. And as you can see here, we can do BVST or Rapid BVST. Next, we need to identify the MAC address that spanning tree will use on the bridge ID. So the MAC address will not be a MAC address for any interface of the switch. Instead, it will be the system MAC address, or you can call it base Ethernet MAC address. In order to see that MAC address, we have to do the command show version. So back to our lab, I will go to switch 3. I will go to the enable mode, and then I will do the command show version. And as you can see, the MAC address will appear here. This is the MAC address that spanning tree will use for the bridge ID. Before we continue, you can do labs for spanning tree very easy and very quickly. So you can challenge yourself, and you will need to drag and drop switches, then go to the command show version, copy the system MAC address, and paste it here. And before connecting the devices, start to guess which interface will be plugged. For example, you can click on the switch, go to the enable mode, and then click show version, copy the MAC address, the base Ethernet MAC address, and come here add it as a text, and after that, start to connect the switches and guess which interface will be plugged. That will help you to build the labs and test your knowledge very fast. One of the important show command for spanning tree protocol is show spanning tree. Inside that command, we can see the MAC address that spanning tree will use for the bridge ID. So let's go back to our lab and do this command. So back to switch 3, I'm gonna do the command show spanning tree. Show spanning -3. And this command give me a lot of information about the spanning tree protocol. Here is the current switch MAC address that is used at the bridge ID. We can do show version, and as you can see, this MAC address match this MAC address on the bridge ID. The output of show spanning tree is little confusing, so let's understand what is the output. First, we have general information about the STP, so the show spanning tree command will show us the spanning tree that is running for VLAN 1. As we mentioned before, STP on Cisco switches plug ports based on VLAN, so this information will be related to VLAN 1 only. Next, we have general information about the root bridge. So we have the priority ID, the MAC address of root bridge, the path cost to reach root bridge, which port we are using in order to reach the root bridge, the hello time, max age time, and the forward delay time. Next, we have general information about the bridge ID for the local switch. Our local switch is switch 3. So we have the bridge priority for switch 3. And as you can see, the system ID extension is 1. We have the MAC address, the hello, max age, and the forward delay time, and the aging time. Also, we have a small table for the interfaces that participate on spanning tree protocol on our current switch, which is switch 3. So we have fast Ethernet 0/1. This interface is alternate block. The cost is 19, and we have something called priority, and the type is point-to-point. We have also fast Ethernet 0/2. This is a root port. This port is forwarding. The cost is 19. The priority is 128.2, and this is a point-to-point link. So back to our lab, and as you can see, when we show the port label, it shows that switch 3 interface fast Ethernet 0/1 is the plugged port. So switch 2 is the root bridge because it has the lowest MAC address. Switch 3 have two equal paths, so the bridge ID will be the tie break. In that case, we have switch 1 with lower MAC address than switch 4. So interface fast Ethernet 0/2 will be the root port, and the interface fast Ethernet 0/1 will be the plugged port. Let's do the show spanning tree command on the root bridge, which is switch 2. Enable show spanning -3. And as you can see here, when we do the command show spanning tree on the root bridge, it tells us this bridge is the root. The root bridge ports will be designated forward. Let's also do this command again on switch 3. Enable show spanning -3. And in switch 3, interface fast Ethernet 0/2 is a root port, and interface fast Ethernet 0/1 in alternate blocking state. The next topic that we have is the configuration for changing the root bridge. So let's ask a question. Why should we change the root bridge in our network? And the answer here will depend on your network. For example, if we have a network similar to this one, it is recommended to make one of the distribution switches the root bridge in your network, because as you can see, the distribution switch has the main connection to our network, so we cannot block one of the distribution switch ports. To change the root bridge, we can use one of those two commands. we can use the command spanning tree VLAN1 priority and then it changes the priority. Please keep in mind that we have to specify the VLAN, and if we didn't specify the VLAN, it will accept the command, but it will not change the root bridge. Or we can do the command spanning tree VLAN1 root primary. Let's change our lab and make switch 3 becomes a root bridge. In order to change the root bridge, we have to be on the global configuration mode. So the command will be spanning tree VLAN 1 root. Let's do a question mark here. So we can make this switch root primary, which will become the root bridge, or we can make it secondary. So secondary will be a backup if the primary fail. Let's make it primary. Let's go back to our topology. Let's speed up the time. And as you can see, our switch 3 becomes a root bridge, and the plugged port right now in switch 2 interface fast ethernet 0/2. Let's do the command show spanning tree on switch 3. I will exit, show spanning tree. And as you can see here, our switch becomes the root bridge. Let's see also how to change the plugged port. In order to change the plugged port, we have to be on the interface subconfiguration mode, and then we can do the command spanning tree VLAN1 cost and then change the cost. So let's do that on switch 2. Since switch 2 has the plugged port, let's see first the cost for the two interfaces. Show spanning tree. So the cost right now is 19 for interface fast ethernet 0/1 and interface fast ethernet 0/2. Let's change the cost for interface fast ethernet 0/2 to 11, for example. Configure terminal, interface 0/2, spanning tree, VLAN 1, cost 11. Let's go back to our topology and the switches exchange the bpdu message now. Let's speed up the time. And as you can see, interface fast ethernet 0/2 become the root port. Let's go to switch 2 and see that. Show spanning tree. And as you can see, interface fast ethernet 0/2 is a root port and it's in forwarding state, and the interface fast ethernet 0/1 becomes a plugged port. The next command that we need to test in our lab is portfast. In order to configure the portfast command, we have to be on the interface subconfiguration mode. So let's connect a desktop to our network and see what will happen. I will connect a desktop to switch 3. Now after I connect the desktop to my switch, so let's enable the portfast on interface fast ethernet 0/3. I will go to interface fast ethernet 0/3 subconfiguration mode, interface fast ethernet 0/3 spanning 3 port fast. And as you can see, it gives me a message that if I did this configuration for a link connected to switch, bridge, or a hub, it can cause a loop. Let's save our configuration and I will do right. Now the configuration is saved. Let's go back to my topology and I will restart my lab. I will choose yes. Let's speed the message. And as you can see, the interface for desktop is in forwarding state. However, the spanning tree still does its own calculation. The next command that we need to test in our lab is bpduguard. So this command can be deployed under the interface subconfiguration mode. This command have to be configured on an end device, but for our lab, in order to receive a bpdu message, we're gonna use switch. Back to packet tracer, I will drag and drop two switches. After that, we're gonna go to switch 0 and enable bpduguard on interface fast ethernet 0/1. Enable conft interface fast ethernet 0/1 spanning tree bpduguard enable. And as you can see, the interface goes down right now. The reason of that, because switch 0 have a bpduguard enable on interface fast ethernet 0/1 and it receive a bpdu message on that interface. If we go back to our switch, exit. Now let's put the command show interface status, show interface status, and as you can see, this interface in error disabled. The reason of that, because we have a security violation which caused by receiving a bpdu message on interface have a bpduguard enabled. Here are some important show commands that we can do for our spanning tree protocol. We can do the command show spanning tree. We saw this command before. We can also do show spanning tree summary, show spanning tree detail, and show spanning tree VLAN, and then specify the VLAN. Those also some configuration commands that we can do for spanning tree protocol. And this is very important. Please make sure to specify the VLAN that you need to configure the spanning tree for. We can do the command spanning tree VLAN, specify the VLAN, and then put mode and change the spanning tree mode. We have also the command spanning tree VLAN priority, and here we can change the priority for our switch. We can also do the command root primary, which will make our switch become the root bridge. We can make it also secondary. We can change the hello time. We can change the forward delay time, max edge time. And if we have a high speed interfaces, it's recommended to use the command spanning tree path cost method long. If we didn't use this command in a network with a high speed interfaces, it will consider the 100 gigabytes interface and the 1 terabyte interface as a regular 10 gig interface. This is the end for this lesson. Thank you for watching and see you in the next one.